Assalamualaikum and very good day to Dr. Rashida. Today my group and I will present our video presentation for MAT210. So first let me introduce my team members, which is me, Muhammad Idham Daniel, and my other two friends, which is Brenda Alexander Damianus and Danish Monosari. For introduction, the theme that is given to us is application of logic in real life. So as you can see here, this is what we use or learn the most in chapter 5 in order to solve our question. So first, the truth table is to implies logical implication in question 2b. We also use a proposition that is tautology, which will be explained by my friend in question 2a. Other than that, we also learn about logical equivalence, validity of arguments, and rules of inference in order for us to be able to answer question 2. We also need to understand how to use law of logic and switching network for us to answer the question 1. So for the question 1, given the logical expression here, draw the equivalent switching network for the above argument. First, we need to identify all of the symbol. If it's the inverted V, which is stand for N, we will use serial circuit, or else the symbol V, which is stand for OR, we will use parallel circuit. As you can see, there are three symbol of inverted V, which is standard for N, that will connect all the expression together. So they all will connect with a serial circuit. But as you can see, Q or R here, it use parallel circuit, as well as in this expression. So first I draw the A and B to symbolize start and end. Then I draw Q and connect it with Q or R with serial circuit. The Q or R will be connected with parallel circuit. Then the expression we used before will be connected with serial circuit to the next question, the next expression, which is in bracket P and Q, that is connected with serial circuit, and Q or R that will be connected with parallel circuit, and this equation is connected to parallel circuit again, as you can see, because it is OR symbol. And lastly, all the equation is connected to P with serial circuit, as it use the inverted P, which is stand for N. I think that's all for the question 1A. After this, I will let my friend Danish to present question 1B, and question 1C. Thank you.
Thank you, Ilham. Now, we will be discussing the answer for question 1B. So, the first law used in order to simplify the logical expression is absorption law. This law is used to simplify Q or open bracket Q and R close bracket into Q. Next, we use associative law to combine the terms P or Q and open bracket Q and R into open bracket P or Q and Q close bracket and R. After that, the idempotent law is used to simplify P or Q and Q into P or Q. Next, the distributive law is used to expand open bracket P or Q close bracket and R into open bracket P and R close bracket or open bracket Q and R close bracket. And last but not least, absorption law is used again to simplify both of the terms we got from the usage of distributive law previously into P and R, and simplification occurs again between the terms open bracket P and Q close bracket or P into P, which results in the final answer Q or P. For question 1C, because the equation changed to Q and P, so we use the serial circuit to connect both of it as to represent the N. That's all. Now I will hand over the presentation to Brandon.
So now I, Brandon, shall present to you about question 2A. So the question is, explain the term of tautology and give a simple truth table for any logical expression using the proposition P and Q to represent the tautology. So the term of tautology is when all truth values of a proposition are true. So basically the result must be all true. If it's not true, if any of those are not true, which is false, then it is not a tautology. So the logical expression that we chose is negation P conjunction Q by conditional of negation P disjunction negation Q. So negation is basically like a not, and conjunction it's and disjunction means it's or. So we only have two variables for this question, just P and Q. So this is how the truth table is supposed to look like. So and then we have negation P and negation Q. So negation P and negation Q is just a mirror of P and Q truth values. So basically if P is true, then negation P will be false, and same goes for Q and negation Q. So we shall continue with the P conjunction Q. So P conjunction Q, same as an AND statement. So basically both of the variables needs to be true in order the results to get true. So if P and Q are both true, then P conjunction Q is going to be true. It's the same as AND statement. So over here we have true and true, so it will result in true, and then true false, false, false true, false, and false false will result in false. And then from that we need to negate this P conjunction Q. So we just flip or mirror the P conjunction Q. So if it's true, it's going to be false. If it's false, it's going to be true. And then you get that. So we proceed to the second part, which is negation P disjunction negation Q. So disjunction works like a or. So if one of the variables is true, then it's going to return true. So basically from this bit we can see that negation P and negation Q here, F and F, it's going to result in false, and then we have false and true is going to result in true. And true false true and true true will be true, and the final truth value for those parts combined with a bioconditional, so it will result in all true. So if the table is all true, means that it's a tautology. So for biconditional, the P and Q needs to be true and true. If it's not true and true or false and false, then it will return false. So true and true, it's equal to true. False and false will equal to false. So in this truth table, it is clear that this is an example of a tautology because all the truth values are true. So now I shall continue with the second question, question 2b. So the question is, determine the validity of the following argument using the truth table. So we have given an argument here. So we have H1, statement number 1, H2, statement number 2, and conclusion. So the first statement is negation R implies P biconditional of Q. And then the second statement is P conjunction R implies negation Q. And then it will conclude with negation P implies negation R. So we have three variables here. We have three variables P, Q, and R respectively. And then we also have the negation of that variables, which is a negation P, negation Q, and negation R. So I have created those, and negation is just a mirror of the normal form. And then we shall move just move to the biconditional part here. So P is biconditional with Q. So biconditional is it's to determine the truth values for the biconditional, like I said from the previous one, it needs to be true and true or false and false, and it will result in true. Other than that, it's going to result in false. So we shall look at this, and so this is the P and Q. So P biconditional with Q. So true and true, true, true and true, 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 false. Alright, so that's a false. True, false again, false, and then false, true, again, false, and then false and false will result in true. Okay, so after that we're going to imply that. So the negation R is going to imply the P biconditional with Q. So basically the negation R needs to be true, and the P biconditional Q needs to be false in order to have a result of false. Other than that, it's going to return true. So from here we can see that if it's false true, it's going to be true. True and true, true, true and true, it will result in true. False, false, true, and then this one, true, false, it's going to return false. And that's how we complete this section for implies. So after that we have a conjunction here, an AND statement, P conjunction R. So again, if it's true and true, it will result in true, and other than that, it's going to result in false. So true, 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 and then we have true, false, false, and then true, 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 and then true, false, false. So and then we continue until the end of the possibilities. So that's how we get for this section, for this part of the column of the truth table. So after that, we're going to imply that. So this P conjunction R will implies the negation Q. So negation Q, which is called a not Q, equivalent to not Q. So this one is a bit tricky because the first statement is this one, the P conjunction R, and then we have to look at the back, which is the negation Q. So if negation Q is false and P conjunction R is true, it's going to be false. You have to follow the order and how it was sorted. So true, false, true, false. So it result in false, and then false, false, true, 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 false, true, true, and then it will continue until the end of the possibilities. And we have H1 and H2. H1 conjunction with H2. So basically from these H1 and H2 that we already done for their truth values, we have to give it a conjunction here, so an AND statement. So basically, again, an AND statement, very simple. So if it's true, false, it's going to be false. If it's true and true, it's going to return true. True, true again, true, and false, true, false, true, 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 false, true, false, true and true, true, true and true again, true. And I label this as A because this argument is so long, so I have to simplify it with just A here. And then the B part here is the conclusion. So negation P implies negation R. So we have to look at the table again from the beginning here, negation P and negation R. So if it's false, false, it's going to return true. If it's false, true, again true, false, 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 true, 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 and then true, false will result in false, and then true, true is true, true, false again, false, true, and true will result in true. So and then I label this as P. So this is the final one, the final section, final part of this table. So A implies B. Basically this H1 conjunction with H2 implies the conclusion, the B, as associated with B. So we'll just look from this table at the top here. So false, true is true, 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 true again, true, false, true, true, and then we have true, false. Alright, so true, false is going to result in false, and then false, true, 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 false again, false, and then true, true, true. So clearly we can see there's a two false here for this end statement here and finalized statement. So it is clear that this argument is not valid. This expression is not a tautology because the truth values of this expression, this argument, it's not all true. We have two false here. So with that, the argument is not valid.
I think that's all from us. Thank you for listening.